So let's start off with number 1 here. They're asking us to use the diagram to name each figure. So what I want you to do is take your finger and your thumb, your pointy finger and your thumb, make an L. What you're looking at there, once you make an L with those, is a right angle. Now what I want you to do is take and pull your thumb and your finger closer to one another. And you're going to see that gap there should be getting smaller. But what you're really making there, as you pull them closer to each other, is an acute angle. Because that's what an acute angle is. It's less than 90 degrees. It's got to have some measure to it, which is why they say bigger than 0 in the definitions. All right? But less than 90. Now, if you take your fingers and go back to that original L position and try and stretch them out a little bit more so they get a little bit further apart, what you're going to be making then are obtuse angles. Obtuse angles are angles that are bigger than 90 degrees. But by definition, they got to be less than 180 degrees. They got to be less than a line. Now, we had that term in there, straight angle. That's all a straight angle is. A straight angle is just a line. All right, now there's some other terms they talk about here. They talk about complementary and supplementary. So go back to that L shape with your finger and your thumb. And now take your pointer finger on your other hand, and what I want you to do is stick it in between the thumb and the finger you've got that you're using making that L right now. Right? Make it point in somehow to those, any angle you want. Something like that. Maybe you want to come in more shallow like that. Or maybe you want to come in really steep like that. Well, when you do that, what you're making are complementary angles. Because those are two angles that add up to make 90 degrees. Together they make that L shape. Supplementary angles are two angles that add up to make 180 degrees. So take your arm and put it out like this, and then take your other hand, take your other arm, and drop it down on top of that arm, something like this. And again, you can shoot it in any angle you want to try, any way you want to be creative, test your flexibility. Whatever angle you create when you drop that in, right, those two together still make that straight line. Those are what supplementary angles are. They make 180. So no matter which way I drop this in, I'm creating supplementary angles, because those two together make 180, together make that straight line. So now with all that in mind, let's use that to help us figure out question 1, where we're going to use the diagram to name each figure. So they're asking us to start off here and name the acute angles. So remember, take and make your L shape with your hand, finger and your thumb, pull them closer together. That's acute. So we're looking for less than 90 degrees. Well, we have two angles here that are less than 90 degrees. This angle right here, which we could call TQP, or we could call it the other way, PQT. That would be one of the angles that's less than 90 degrees. And then we've got this angle over here, which we can call SQR or RQS. Notice I'm using all three letters when I call the angle, and I call them in order. If I start with T, I follow it around so I finish the angle, which is why I came up with TQP. Or if I start with P, I follow it around until I mark off the whole angle, PQT. One thing I never did is I never started with Q. Because if I start at Q, I can only get to T or P for this angle, but I can't get back around because there's no line that connects going that way. So make sure you call your angles in order and use the three letters. You don't want to just say something like Q here either, because notice there's three angles that have a vertex at Q. This angle has the vertex at Q. This angle here has the vertex at Q. This angle here has a vertex at Q. So calling it Q by itself is not sufficient. Now, in B, they're asking us for obtuse angles. That's two angles whose sum is bigger than 90 degrees. So if you make that L shape again with your hand and then try and stretch it out a little bit, that's going to be an obtuse angle. Now if we look at just what we have here, none of those angles by themselves are obtuse. But we can put some things together to make obtuse angles here. If I take and put these two to the left together, that is clearly bigger than 90 degrees. Right? The L shape would make this come straight up. Well, it's bigger than that. So those two together, which we would call PQS or SQP, has to be an obtuse angle. And you can see what they're doing there is they're showing you the sums when I add these two up. To make that angle, I get 133, 90 plus 43. I can do the same thing heading the other way here. I can put those two together, the 90 and the 47, which forms RQT or TQR, and that makes, in this case, 137, which would also be obtuse. Now in part C, they're asking for complementary angles. Complementary angles, again, are two angles whose sum is 90 degrees. So when we're looking at this question, this angle here is out because by itself, this makes 90 degrees. That doesn't work. We have to have two angles or more that add up to make 90. But if I add this guy up and this guy up, 43 and 47, those two together do make 90 degrees. So what they say here is that TQP, which is this angle, and RQS, which is this angle, put together, make 90 degrees. Finally, they're looking for supplementary angles. Supplementary angles are angles together that make 180. So a few different ways you can go here. You're going to make some kind of clever angle pairs here, but we can group these two together, which we know from the problem we did earlier are 133, and if I add it to this guy here, which is 47, that's one way I can get my 180 degree set, which is what supplementary angles are. So I could say that PQS, or SQP, whatever you want to call it, and SQR, or RQS, is a set of supplementary angles. Now they're going to do the same thing here, but now they're going to work this going the other way. They're going to put these two together, 90 and 47, which makes 137, and add it to this guy here, 43. Well, those two together also make 180 degrees. So we're going to say that RQT or TQR, whichever way you want to call it, and TQP or PQT, whichever way you want to call this one, together make 180, make your supplementary angles. Now we'll take a look at question 2, where they're asking us to use the diagram to find the angle measures. Now what you see on the screen to you in that illustration probably looks like a giant X. And if it does, that's a good thing, because that's what I'm hoping you're seeing. What we're talking about here in this particular question are vertical angles. Vertical angles are angles that are across from each other. Angles that are across from each other, vertical angles, have a property, and that property is congruence. Congruence is the geometry way of saying equal. When we're talking about numbers that are equal, when we're talking about shapes that are the same, they would be congruent. So, for instance, if I'm looking at angle 2 here, angle 2 is the exact same as angle 4 because they are across from each other. So, if I tell you what angle 2 is, let's just say I say it's 112 degrees, angle 4 also has to be 112 degrees because those two angles are vertical angles and they're across from each other. What we're also going to talk about here are supplementary angles. And there's a lot of supplementary angles here. Remember, supplementary from the last example refers to two angles together that make 180. Now, since this first question is asking about 1 and 2, let's talk about 1 and 2. So 1 and 2 together lie on this line. Let's pretend for just a minute that this line isn't even there. So if I'm just looking at that line that goes from left to right, this one, well, that's a straight angle. A line is a straight angle. By definition, those have to make 180 degrees. The angle that consumes is 180 degrees. Well, those two angles then, because they rest on that line together, have to make 180 degrees. Well, what they're telling us here in part A is that this one is 37 degrees. So all I have to do to find angle 2 is figure out how much more I need to get to a full 180 degrees. Well, that's pretty simple because if this is 37 degrees, I'm just going to subtract from 180 and that's going to give me angle 2. And that's exactly what they're doing here. They're doing 180 minus the 37. 180 minus the 37 gets me to 143. And indeed, that would make good sense. We can check it, go back the other way. 143 plus 37, does it make 180? Yes, absolutely. 143 plus 37 makes 180, so our work makes good sense. Our answers are going to check there. Angle 2 has to be 143 degrees. Let's keep rolling here with question number 3. Question number 3 says a traffic engineer designed a section of roadway where 3 streets intersect. Based on the diagram, what is the measure of angle DBE? So let's look at what we've got here, and I'll pull up the magnifier for just a second here, so you can see that in this illustration here, you've got this backwards L shape. That shape always indicates the presence of a right angle, an angle that measures 90 degrees. So we already know now, simply from that alone, that this angle here has to be 90 degrees. Now we were also told, simply in the illustration, that this angle up here is 26 degrees. And that's really all we need here. We're finding how large angle DBE is here. Well, DBE starts here at D, goes to B, and follows down to E. So that's this angle in here that I'm now shading in yellow. Now some of you might be saying, well, wait a minute, you're covering up the 90. No, remember the 90 is this entire upside down L shape here. Right here, that L shape is 90 degrees. But they're only asking about the angle between these two lines, which is just part of the 90 degrees. But we have to figure out what part of the 90 degrees. Now, I want you to pay careful attention here because there's a question just like this on the homework. They're talking about finding the measure of angle CBD to start off here. Why? Because we know that this whole thing is 90 degrees. If I can figure out how much this chunk is, I can then take that off 90, and that would be how much that this chunk is. So they're going to talk about finding CBD here. Well, the good thing about that is that's pretty easy. Because if I forget that this line is there for a second, what you see is that X shape is being created there. And remember, that X shape refers to vertical angles, angles that are across from each other. And vertical angles, by definition, are congruent. So if I know this is 26 degrees, then this one is also 26 degrees. Well, that unlocks the whole mystery now, because I know that this entire angle is 90, and this little chunk here is 26, so I can figure out what this chunk is to make these two add up to 90. And that's what they're doing down here now. They're doing it like an equation. So they're saying that this angle and the 26 that we found have to make 90 degrees. Well, if I subtract 26 from both sides, which is exactly how I would do this, I find out that CBD has to be 64 degrees. Well, that's even better for me because this is 64 degrees. That's the chunk I needed to know about. So here we now have the answer to the question in 64 degrees. Please change your note-taking guide to reflect that this last line needs to be corrected. This should actually say the measure of angle DBE. Right, that is the angle we were looking for. Notice they eliminated CBD up here when they changed it to 26, but they mistakenly left CBD in instead of DBE. So what I should have said, what the note-taking guide should also say, both need to be corrected, is that DBE, the angle we were looking for that we highlighted in yellow, is 64 degrees. Let's go ahead and take a look at the check it out examples for 7-1 and finish this up. In number 1, they're asking us to use the diagram to name the figure. And they're asking us to name a pair of supplementary angles. So recall, what does supplementary mean? Supplementary means that it's two angles that add up to make 180 degrees. if you're having a hard time keeping supplementary and complementary straight, think of the S in supplementary as being the same S as in straight angle. And that should help you because a straight angle is 180 degrees and supplementary angles are also 180 degrees. So we've got to make two angles here that add up to 180 degrees. So somehow, some way, we're going to have to pair some things together. Now what they've done is they decided to work with CED as an angle of its own. And that is 75 degrees. So we need a partner that's going to go with it that's going to make 105 degrees. Well, if I put these two angles together, CEA or AEC, whichever way you call it, that's going to make that 105 degrees that I need to make supplementary angles. Now that's not necessarily the only option here, even though that is the option that the note-taking guide uses. We can go back for a second and pair these in a different way. We could pair together DEB, right, which is the angle that's marked 75 and the angle that's marked 90 put together make DEB. Well, that is a rather large angle, but what we see here is that's 165 degrees. Well, I need an angle that measures 15 degrees to pair with it to make 180. And indeed, this small angle here is 15 degrees, so AEB would pair with it to make my 180 degrees. Both answers, even though they've listed only the one on the screen, are perfectly acceptable. Now let's take a look at the concluding question, question 2, where they're asking us to use the diagram to find the measure. And they're telling us that angle 1 is 42 degrees. Well, let's start with the one they actually aren't asking for here. Let's go ahead and take a look at the one marked 3. 1 and 3 are directly across from each other in that X shape. So those are vertical angles. Vertical angles have the property of congruence. So if we know one, we know the other. So if that one is 42 degrees, this one is also 42 degrees. Now we can use either one of those to help us find angle 2 here, which is what they're really asking for. And the same work and logic would also flow for question 4. Realize that 2 and 4 are also a set of vertical angles. They're across from each other in that X. So they also have to have the same measure, as in the same measure of each other. So let's look at 1 and 2. Together, if I ignore this line that's shooting off here to the left, what you have there is a straight angle or a line. Those two together have to make 180 degrees. They are supplementary angles. If I know that this segment is 42, what I'm really asking myself is how many more do I need to make this angle to make these two together reach 180 degrees? Or in other words, simply 180 minus 42. When I do 180 minus 42, I get 138. And indeed, you can see that matches the answer on the board. This angle here has to be 138 degrees to match this 42, which makes a line. The same logic would flow this way. 138 here plus 42 here would make 180 for that line as well. And again, when they make 180 together, that's referred to as supplementary angles.